Cellular regulatory processes are more complex than we had once imagined. We now understand that it is generally not individual genes, but networks of interacting genes and gene products which collectively interact to define phenotypes and the alterations that occur in the development of disease. The inference of such gene networks is a challenging task, but if successful, may bring new insights into disease biology while providing us with new diagnostic and predictive tools to improve public health. Given its potential, gene network inference is an intense field of research. In this video, we'll be introducing the Predictive Networks web application, a flexible, open-source, web-based application and data services framework that enables the integration, navigation, visualization, and analysis of gene interaction networks. The primary goal of Predictive Networks is to allow scientists to evaluate gene lists in the context of large-scale gene interaction networks built from a comprehensive collection of known gene interactions extracted from public resources, including full-text articles in PubMed Central, as well as from users' own genomic data. To catalog known interactions, we've developed a sophisticated text mining pipeline that extracts gene-gene interactions from both full-text articles archived in PubMed Central and elsewhere, and abstracts in the PubMed database. The relationships inferred from these publications are synchronized and aggregated with structured datasets from publicly available pathway databases and presented to users through a rich graphical web application that allows users to upload, merge, share, curate, search, and analyze gene lists and associated networks inferred from known interactions and genomic data. For network inference, we've implemented both previously published and novel inference methods that combine cataloged interactions and user-supplied gene expression measurements to infer and visualize predictive network models. Let's move now to a demonstration of the application. Let's start with a basic gene-based search. On the left-hand side, we can enter our query of interest and search. Here we find our gene of interest, BRCA1, and we'll click to view details. Annotations of the BRCA1 gene are displayed at the top of the page, and below that, genes that are most often cited as interacting with BRCA1 are displayed as a directed graph. Several options are available to identify the most interesting interactors, such as context, connectivity, minimum number of citations for each interaction, and the maximum number of genes to display. Below this, a gene name cloud is displayed, allowing users to easily identify the most studied interactors, and to click on them for further annotations. And at the bottom of the page, we have a list of sentences extracted from PubMed to help users better understand the context of where these interactions were found. Data from the detail page can also be exported by the user. For example, our network graph can be exported as an image, and the triples, that is, the relevant pieces of information we've extracted from the sentences, can be exported in a variety of different formats. Now we'll perform a new type of search. Here we'll search for gene interactions to see whether a specific interaction has already been reported in the biomedical literature or in a pathway database. So let's search for known interaction between BRCA1 and TP53. We click search, and as expected, these two famous oncogenes are reported to interact in various circumstances to give rise to aggressive tumors. We can select one of these and see a related context as well as the sentences that have given evidence for the interaction. And finally, we can search for a list of genes to identify all known interactions for a gene set. Here we'll again enter BRCA1 and P53 as well as AKT. We click search and we come back with a graph of known interactions for these genes. We can modify the graph by clicking and moving individual members and by changing some of the parameters. Here we'll increase the number of genes to 30 and apply these changes. Finally, we can highlight individual members using the drop-down list at the top, and here we can specifically highlight AKT. In addition to search and retrieval of identified interactions, we can also use the Predictive Networks application to perform a network analysis. For this, though, we need to log into the application first. We'll enter our credentials. And to get started with the new analysis, we first need to upload our own data. We'll go to My Page, and we'll first upload a gene list. Here's a list of PI3K genes. Give it a name and upload. Next, we're going to upload a set of interaction gene expression data. Again, we'll browse and upload this from our local computer. And here we see it's been added to the system. Next, we'll click to create a new analysis. We'll give it a name. Again, we'll call it PI3K. We'll select the data that we've already uploaded, our gene expression data, and we'll use the list that we just uploaded as well. We can see a number of advanced parameters for the analysis, but we'll just go ahead and click Run Analysis to use the defaults. When we go back to the My page, we can see the status of our analysis here in progress. In just a few seconds, our analysis is done. We can click the name, and this brings us to an analysis result page. Here we can see the specific parameters that were used to create the analysis, as well as the various outputs that are created. Some of the data files that are produced include a GML file, which can be loaded directly into the Cytoscape application for network visualization, and some of the outputs can also be visualized directly in the Predictive Networks application. As an example, we can view the inferred network topology with a heat map by clicking on the link. Here again we see our identified network, which we can manipulate by selecting in the graph. And we also have a heat map, which shows us known interactions, inferred interactions, as well as those interactions that were identified as both. We realize that users might want to share information with their colleagues about the networks that they are deducing through their analysis. Through My page, users can upload their own interaction networks, either inferred from the web application or any other tools into the system, and publish these so that others can use them. By doing so, we hope to develop a community-based tool to allow collaborative development of a comprehensive gene interaction network knowledge base. For feedback and suggestions, please contact us at info@predictivenetworks.org.